Hello, hello. In this section, we're going to talk about irrationality. There's a little story that a father calls his son and says, "Son, after 30 years of marriage, your mother and I just decided to get divorced." And the son is saying, "Oh, this is terrible, this is awful. I really don't want you to do it." The son says, "You know what? I'll come home, just don't do it yet. So let's talk about it." He says, "You know what? I'll call my sister. We'll be there the day after tomorrow. Just don't do anything until we have a discussion with you and mom." And the father said, "You know what? I promise you. We'll wait. We'll see you the day after tomorrow, and then we'll have a discussion." He puts down the phone. He turns to his wife, and he says, "Darling, this year the kids are going to come home for the holidays, and they're paying for their own flight tickets." So when we think about irrationality, what is it about? It's about the forces that drive our behavior. Some of it are economic forces, some of it are social forces. And in this particular section, we're going to look at all kinds of influences on our behavior. We're also going to look at choice architecture. We're going to look at how the world around us and how it's structured changes how we view things and how we make decisions. We're going to look at how initial decisions are going to have long-term influence on us. And finally, we're going to think about what we can do to do things better. What can we do to try to overcome some of our irrational tendencies? I would like to argue that when we think about irrational behavior, this is something that is important both for our personal life, as well as our social life, and as well as for our work life, and of course for policy. And to get us started thinking about it, I would like to tell you my own personal case and how I became interested in when and under what conditions we behave irrationally. So as you could probably tell, I was badly injured many years ago. I was burned in about 70% of my body, and I spent about 3 years in hospital. And hospitals gives everybody who spends time there many opportunities to examine and think about irrational behaviors. And in my particular case, there were lots of examples, but the thing that focused all my attention, the thing that kind of made me think every day was the question of bandage removal. So consider the following question. Imagine you were, like me, burned in 70% of your body, and you were covered with bandages, and every day the nurses had to remove your bandages. And ask yourself, what is the right way to remove these bandages? And we can think about two very distinct strategies. One is to rip the bandages off quickly as possible, one after the other, minimizing the duration of the treatment, but making each second of it incredibly painful. The second approach is to rip the bandages off slowly. Take a long time, but make each second less painful. Consider to yourself, which one of those strategies would you pick? Which one? When I ask lots of people about this, most people say they would prefer the ripping approach. And that's actually the approach my nurses liked as well. I always, by the way, thought that the reason they had this intuition that this is a better approach is because that's how they used to wax their legs, kind of in the ripping version. But removing hair is not the same as removing bandages necessarily. So which one is the right approach? As a patient, I used to feel that they were not doing the right thing. I used to argue with them and plead with them and say, "Please take more time, make it slower, don't rip the bandages as fast." But the nurses told me two things. The first thing they were said was that they were right. They knew what is the best thing to do, what would minimize my pain, right? In some sense, they said, "Who are you, the patient, to question our judgment as professionals?" And the second thing they said was that the word patient doesn't mean to butt in or intervene or make suggestions. It means to be passive and just sit there patiently. In fact, this was in Israel, where I grew up, but the word patient has this passive component in any language I've seen so far. So the nurses kept on doing what they thought was the best thing to do, which was to rip the bandages off quickly, and I kept on complaining, and we kept on in these roles for quite a long time. About 3 years later, when I left the hospital, I started studying at the university. And one of the first interesting lessons I learned was about the power of the experimental method. And what I particularly found interesting is the idea that if you have a question about almost anything in life, you can pose it to an experiment. You can say, here is one version, here's another version, let's see which one wins. So I decided to try this out. Now, if you think about it, this question of how people aggregate information over time is very general. Imagine that you have an axis. You have time and you have intensity. And you have experience that can vary in intensity in all kinds of ways. You can have movies. What happens if we have a movie and we have really good 5 minutes? Are they better off in the beginning, the middle, or the end? What if we can take an opera or a concert and make it 10% longer or half an hour longer? Are we making it better? By how much? So these questions of how people take an experience that vary over time and aggregate the information is actually quite general. But for me, the main issue was pain. I wanted to understand how this works in the domain of pain. So initially, I didn't have much money for research, so I went to a hardware store and I bought a carpenter's vise, basically something like this. And I set up this carpenter vise in the lab, and I invited people to come into the lab and put 2 fingers in this vise. And I would crunch people's fingers a little bit. And I would crunch their fingers a little bit for long durations and short duration, high intensity and low intensity, pain that goes up, pain that goes down and down and up, all kinds of versions of pain. And after each of those painful experiences, I would ask people, and how painful was this? And how painful was that? This is kind of just rating scales, from not painful at all to the most painful I can imagine. And then I would ask people to make choices. Which one of the last 2 experiences would you like to repeat again? The last one or the one just before it? And people gave me their choices and their ratings, and I was trying to infer how people combine these experiences. And I finished the first paper. I learned some lessons. I published it in an academic journal. And then good things happened. I got more money for research. So I moved to better equipment. I moved to something like this, which are a mechanism to create annoying sounds in different intensities. I did experiments with electrical shocks over time. I even created a pain suit. I created a suit with 300 feet of hoses stitched through it. And with this suit, I could get people to be very hot and very cold. And then I could relieve that pain in many different ways. And what did I learn from all of those experiences, in all of those experiments? I learned that the nurses got things wrong in multiple ways. First of all, in terms of the question of duration versus intensity, it turns out that if you take an experience and make it twice as long, you don't make it twice as painful. So the nurses were trying to minimize the duration, but they were not doing the right thing. On the other hand, when you play with the intensity, you make something more intense, now you're really changing how people experience it. So what the nurses were doing, they were trying to minimize the duration at the cost of the intensity, but by doing so, they were not saving me much, but they were making it much more painful. And not just for me, by the way, for all the other patients. The second thing the nurses failed to understand was that progression over time matters a great deal. When you start with the low pain and you increase pain over time, this is much, much worse than starting with the high pain and going down over time. And mostly for reason of convenience, the nurses started at my legs and ended up at my face, which gave me the wrong progression of pain over time. And finally, it turns out that for really long periods of pain, it's good to get people a period to kind of recover, recuperate, and prepare themselves for the next period of pain. And again, this was something that the nurse did not get. Now, when I finished doing these experiments about pain and pain perception, aggregation of pain, I went back and I talked to the nurses, and all kinds of things have changed since that. But the thing that puzzled me the most was, how could the nurses get it wrong? Here were kind people, wonderful people who were spending hours in terrible conditions to serve their patients. And they were not saying, you know, I don't know which is the right way. They were convinced that the right thing to do was actually the thing that was wrong. It's not as if they say, I just don't know what the right answer is. No, they actually had a strong conviction that they knew what the right answer is, but that was not the right one. And then, of course, the question is, are nurses the only people who have the wrong intuition? Are nurses the only people that says, this is what I think is the right answer, when in fact it's the wrong answer? And from that point of view, from that starting point, I started looking at all kinds of behaviors, all kinds of things in which we have good intuitions, we have good intentions, We trust our intuitions, but in fact our intuitions are misleading us time after time. And this is for me kind of the starting point of irrational behavior. Things that we think we know how they work, we think we know what's the right thing to do, but in fact we're wrong. So let's think about some of those. Now, to get you an intuitive example of how these things work without inviting you to the lab and to squish your fingers, I want us to think a little bit about visual illusions. So consider the following illusions. You have two towers of Pisa here, one on the right and one on the left, and now think to yourself, which one leans more to the right? If you're like everybody else on the planet, you think that the one on the right is leaning more. But what about the following thing? Now, again, if I ask you the same question, again you would think the one on the right is the one leading more to the right. Now, of course, those just switched in front of you, and you know that this is a visual illusion. Now, what's interesting about visual illusions is that everybody gets it wrong. It doesn't matter how old you are, how young you are. It doesn't matter how much experience you have in vision. As long as you can see, you would get it wrong. Here's another visual illusion. This is one of my favorites all-time visual illusions. Look at this cube. The top arrow, to what color is it pointing? You probably think it's about brown. What about the bottom one? Well, looks orangish. Turns out they're identical. Can any of you see them as identical? Of course not. Now what happens if I cover the cube up? Now you can see that both of those patches are actually identical. And by the way, there's no trick to it. These are really identical. And here's the other interesting thing. Now the illusion pops right back. Knowing that those two things are actually the same doesn't help you in any way to see them as identical. Now there's something else interesting in this illusion which we'll come back to later, which is that this illusion is all about the way that the brain uses relativity. Many times what you think to yourself you're doing is you're comparing the top patch to the bottom patch. But that's actually not what your visual system is doing. What the visual system is doing is comparing the top patch to its immediate environment and the bottom patch to its immediate environment. And because of that, you get this illusion. You think to yourself that you can compare both patches correctly, but you can't. When we'll come back to it, you'll see how it comes about, this illusion, in all kinds of other areas of life, including pricing, for example, and how we're using background context to evaluate and think differently about what we're comparing. There's one more type of illusion I want to share with you, and I'm going to show you a couple of examples of those. And this is a different kind of illusion because it only works once, so pay attention. So in the next clip, what you're going to see is a group of people holding iPads, and they're going to move the iPads. And the iPads are going to change colors. And your task is to count how many times they change into the color red. Every time something changes from one color to red to something else, you count it. And then another iPad changes to red, you count it. And your task is to count how many times all the iPads across the whole clip change into red colors. Now, don't get too technical. If something looks almost like red or slightly pinkish, it's okay. Count it as red. Okay? So, before we go though, I do want to say a couple of things. First of all, it turns out, and there's a lot of research about it, showing that people who do well on this task, people who count well on this task, do well in terms of their love life. They have a better romantic life. And the second thing is that those people who do well on this task live longer. So if I were you, I'm just saying, if I were you, I would focus. I would count well because remember, what's on the line here is your romantic future and your longevity. So, count carefully how many times how many times the iPads are switching into red color. Ready, set, go. So how many did you count? You count 50, 60, 70, 40, 20? How many? The real number is 62, but the reality is that that doesn't matter so much. The reason I really asked you this question was not to ask you how many times the iPads are flashing red, but to ask you a slightly different question, which is, did you notice me in a particular bee suit hovering around the scene? Did you notice me at all or not? Let's look at it again. And this time try to pay careful attention, not to the iPads, but to the total scene. And let's see if this time you can see me floating around. And just to be clear, this is the same exact clip. And if you don't believe me, luckily you have the video. Go back and you can look at the first clip again just to prove it to yourself beyond a shadow of a doubt. I hope that, like me, you find this quite startling. You look at a small part of the screen, you focus, you look very carefully, and nevertheless, something unexpected happens around the screen and you're able to ignore it. It's a tremendous ability of human capacity. And the reason for that, by the way, is that we don't see with our eyes, we see with our brains. Our brains expect us to see a particular pattern, and that's what we end up seeing. Now we think we see with our eyes. We think that we observe all the information, but we don't. And just as another example of that, do you remember what shirt I was wearing before we started this clip? Well, you can go back and check to yourself, but I have a different haircut, slightly different shape, actually very different shape, slightly different shape, and a different shirt. And I bet you didn't notice those changes either. I hope you agree with me that it's really kind of amazing to see how much we don't pay attention. You know, we usually think that we see with our eyes, but the reality is we see with our brains, and our brains fill in the information in a way that we expect to see it. Not necessarily what it is out there actually, but what we expect to see. Now, why do I start with talking about decision-making and irrational behavior by talking about visual illusions? I think visual illusions are a great metaphor that help us to think about human thinking. Think about it. We have a huge part of our brain dedicated to vision. We have a huge part here in the back dedicated to vision, does vision all the time, bigger part of the brain that is dedicated to anything else. We do vision many hours of the day. We're evolutionarily designed to do vision. If you had to pick one thing that people are good at, it's vision. And nevertheless, we have these mistakes. You'll always see the pizza illusion. You'll always see the cube illusion. And the question we should ask ourselves, if with all these benefits, huge mechanism, lot of experience, evolutionary reasons to do it, with all of those reasons to do vision well, we still have predictable, systematic mistakes in vision, what are the odds that we don't have even more mistakes in other areas of our lives? What happened to decisions about healthcare, decisions about money? Those are areas where we don't have a particular brain mechanism, we don't have that much experience. Evolutionarily, these are much newer things. Couldn't it be that in those areas we would have even more predictable and systematic mistakes that everybody shares? And for the rest of the discussion, I want to present to you the case that this is indeed so.